Hello everyone, this is a Priyanshu Choubey, Assistant Professor of Soil and Biology. Today we will talk about the soil air and soil air, how to influence a plant growth. So let's see what is a soil air. Uh, Soil physical property, one of the soil air is a very important part. The soil physical properties such as the texture, structure, porosity, bulk density, and the moisture content largely control the composition of soil air. Sandy soil have a low total porosity, but the size of pores is big, whereas the clay soils have high total porosity, but the size of the pores is small. The soil with bigger pores promote a rapid exchange of gases than a soil with a smaller pores. Therefore, the composition of soil are a many of change in sandy soil. The soils of a stable structure have a large volume of a micropores is 0.06 mm more than equivalent diameter and contain the amount of oxygen equivalent to its content in atmosphere. On the other hand, puddled or flooded soil are a high their carbon dioxide content due to a limited aeration. The reduction in the volume of a micropores upon a compaction leads to increase in carbon dioxide and decrease in oxygen. The restriction is diffusion of gas with increases in soil moisture, increase the concentration of carbon dioxide in wet soils in waterlogged soil gases like sulfur ha- H2S and methane and nitrate and may accumulate that have adverse effect on the plant roots since the surface soil diffuses directly with the atmosphere, therefore has a relatively higher oxygen as compared to subsoil. It is a process the circulations of air in the soil. Respiration, the rate of respiration by a plant roots and microorganisms is the major cause increases of the variation in the concentration of oxygen and carbon dioxide in the soil, which is affected by the soil temperature, moisture, and type of soil organism. Soil organic matter and the biological activities, addition of manure, crop residues, sewage, slag, or other organic matter affect the composition of soil air to large extent during the process of microbial decomposition of these materials. The concentration of oxygen decrease and that of carbon dioxide increase. Next one is cropping. The growing plants tend to reduce oxygen and increases carbon dioxide concentration and due to a root respiration and the biological activity associated with the crops also tend to increase the concentration of carbon dioxide as well. Tillage, the exchangeable of gases and faster in tilled soil, shallow tillage encourage carbon dioxide in the top soil in comparison to a deep village puddling required for a growing rice decreases the microporous and the result in the poor irrigation for the succeeding crop like a wheat. Season the composition of the soil air changes with the season primarily due to change in the soil temperature and moisture in a rainy season soil have a lower oxygen and a higher carbon dioxide concentration as compared to suburban soil are dry and there is a better opportunity of gas exchange. But is warm season to higher microbial activity, more carbon dioxide may be reduced, the concentration of carbon dioxide increases the ranks because of increased decomposition of organic matter and slow process substitution. Soil aeration Soil aeration is the process of exchange of oxygen and carbon dioxide between a soil air and atmosphere. Soil air replenishes oxygen consumed and prevents accumulation of carbon dioxide involved evaporated during the respiration of plant roots and microorganisms. Irrigation status of soil is usually characterized by the leaching process of gases exchange, the exchange of gases between an atmosphere renewal of a soil air. It is a natural process which involves two mechanisms, namely mass flow and diffusion. So, air movement in the soil. First one is mass flow. It means a response to pressure gradient, but a mass flow or of air occurs due to total pressure gradient of gases, which uh, causes movement of entire mass of area from the region of higher pressure to the region of lower pressure. Mass flow of air may occur from atmosphere to soil or vice versa and from an location to another in the soil. The difference in total pressure may arise due to a meteorological factor such as a temperature, pressure, wind, and the air replacement due to a rain and temperature. First one is a temperature. As per Charles' law, air pressure is directly proportional to the air temperature at a constant volume. So whenever there is a temperature gradient between the 2 points, pressure gradient also develops, which causes gas to move. A temperature difference may arise within soil or between a soil and atmosphere. Therefore, a movement of air may be between the soil and or between a soil and atmosphere. Pressure as per boiler law, volume of air is inversely proportional to the pressure at constant temperature. With increase in pressure in the atmosphere, the volume of soil air decrease, resulting in a movement of air from atmosphere to soil. As the pressure in the atmosphere decreases, the volume of soil air increases, which causes the movement of soil air to atmosphere. Rainfall and irrigation displace the soil air as such to the lower depth when water is lost from the soil by evaporation, plant uptake or deep drainage, the air moves from atmosphere to soil. Wind presence and suction's effect of high wind causes the exchangeable of gases between the soil and the atmosphere, but the effect is restricted to surface alone. Now, diffusion. Diffusion is response to concentration gradient and random molecular motions. Diffusion is the predominant process of soil erosion. In diffusion, individual gas constituents move sep- separately due to partial pressure gradient, but the total pressure of air may be the same. When partial pressure of carbon dioxide in soil air increases due to root and molecular microbial activity, the carbon dioxide diffuses from soil to the atmosphere. Similarly, when oxygen in soil air is consumed for respiration, its partially pressure is reduced and the oxygen diffuses into the soil. Diffusion increases with increases in temperature. Fick's Fick's law of diffusion. It shows here as per Fick's law of diffusion, flux of a gas across the plane is proportional to the concentration gradient. Um, Fick laws of diffusion here showing how F capital F is equal to minus T upon dc upon dx, where F is the flux of gas constituent in X is a direction. D is the diffusion coefficient. DC is a change in the concentration in the small distance dx, and dc upon dx is the concentration gradient of the gas constituent. The flux gram centimeter square minute is inverse refers to the amount of gas diffusing in the unit time across a plan of a unit area. The equation of ideal gases is a PV is equal small m RT, where P is the partial pressure of gas and V is the volume of gas and is the number of molecules of the gas. R is the gas constant 8.3 J inverse mole inverse and P is the absolute temperature. Therefore, N is N upon T is equal to C and P is upon RT, where C concentration. Substituting the value of C is K Q small q is equal minus T upon dx in bracket P upon RT is equal to minus T upon RT d small dp upon dx is equal to minus T upon d dash upon dp and dx. So where d dash are the constant, therefore d is a diffusion coefficient where the gradient is expressed in the terms of the partially presence of individual gas constituents. The coefficient of the diffusion of the gases depends on the actual structure and the moisture content of the soil. The rate of diffusion increases with the temperature. Under drier condition, the diffusion of gases is a higher in kind than the process structures. Under a moist condition, The behavior is reversed as the pores will be more in the porous structure soil. Factor affecting soil aeration. So the volume of microspores after the total air and gases exchange in the soil. The volume of this porous largely depend on the texture, structure, degree of compactions, and the depth of soil. Due to a large volume of the microspores and porous structure, dew soils have adequate aeration than fine textured soil. Due to this, the concentration of carbon dioxide is higher in the fine textured soil. Puddled soil have a more carbon dioxide content due to a poor aeration, while aggregated soil may have some patches of a poor aeration due to the presence of compacted uh, soil layer. Topsoil are usually deficient in oxygen due to the reduced volume of matters. Soil characters, characterization of soil aeration status. Soil aeration status may be characterized by determining the concentration of oxygen and carbon dioxide in the soil using chemical gases chromatographic method. The air-filled porosity and air permeability can also be used to determine the aeration status of soil. Other methods include the determination of diffusion coefficient of gas and redox potential of the soil. However, the best method of characterized of the aeration status through the measure of oxygen diffusion rate. In short form, we can say ODR. The ODR is the rate of which oxygen is replenished when it is used by plant roots or a microorganism. The ODR meter is used to measure ODR. The critical value of ODR of soil is 220 into 10 to the power minus 8 grams centimeter square minute inwards below which the core roots of most plant is. The optimum ODR range for a most crop lies between 30 to 20 to the power minus 8 gram centimeter per meter minute inwards to 40 to 20 to the power minus 8 gram centimeter square minute inwards. The ODR decrease with moisture and the depth of soil. A soil condition where the ODR is the least 30 to 10 to the power minus 8 grams centimeter inverse the oxygen concentration of soil. Soil air is the least 10% in the root zone is considered as having adequate aeration. Management of a soil air aeration. The soil aeration can be optimized by managing soil structure, soil temperature, proper drainage plant adaptations, and regulations of soil structure may be improved by addition of farmyard manure, crop residues, growing crops and tree crops. Uh, in order to increase the volume of macro spores, the fine pores retain water longer time, inhibits oxygen diffusion, therefore necessary to avoid crusting and the soil compaction. Drainage, surface and subsurface drainage um, of air is essential for supply of sufficient oxygen where soil becomes saturated due to a continuous seepage from canals, pits, or a high water table. Heavy rain or irrigation, the drainage will decrease the moisture content and provide aerobic environment in a soil. Cultivation, a shallow shallow cultivation of soil and a culture operation control the field and have in exchange of gases, especially in the properly trained agricultural soil after rain. If dust of is formed, may hinder the gases exchange. Light cultivation will help in improving soil erosion. For the improvement of a soil erosion is typical earlier planting included crops or soiling and the vertical mulching and the option of the organic residues into the cuts into the subsoil are very useful. Temperature and increase in the soil temperature decrease the oxygen diffusion rate, enhance the microbial activity can rise carbon dioxide production in the uh, soil. The net result of increase in the soil temperature on the partial presence of the oxygen may therefore may be earlier positive and negative in such situations. Mulching applies an important role as a mulch protects the soil from the impact of the raindrops and therefore the helps in the retaining the till. This mulching facilitates irrigation, but it also keeps the soil moist and restricts the soil irrigation deposit or negatively affected. The mulching on oxygen diffusion rate depends on the individual situation. However, it has been observed that the mulching usually decreases oxygen diffusion into the soil. Plants adopt Adaptations are plant adaptations plant root in general are adapted to aerobic conditions. However, some of the plant species develop mechanisms such as increases in the air space of root porosity or internal erosion through leaves and the cardiac cell and the grow well even in oxygen deficient soil. The selection of the crop species therefore is the important of for a growing crops in a waterlogged or a properly drained soil. For example, uh, thrives well submerged soil conditions. Soybean crops can tolerate temporarily waterlogged conditions better than a crop like maize, peasant pea, and deep rooting crops. Regulations of root aspiration. Soil aeration may be managed via regulating respirations of roots and the microbes via fertilization culture practices, plant population and uh, incorporation of organic residues into the soil. Crops of a lower oxygen requirement or a shallow root system may be grown in situations where on the surface soil has some degree of irrigation. One of the most important method for measuring a soil irrigation is ODR. ODR, oxygen diffusion rate. So technique for a measurement of ODR, its principle when a certain electric potential is applied between a platinum electrode inserted into the soil and reference electrode oxygen is reduced at the platinum electrode surface. So the general reaction taking place at the platinum microelectrode surface in the reduction of oxygen is in two steps involving two electrons in each step. There are reactions in two different media or in acid soil. In acid soil, oxygen plus uh, two hydrogen ions plus electrons is equal to H2O. H2O plus two hydrogen ions plus two electrons so is equal to H2. So oxygen were separate and the four hydrogens there and the four electrons there and two H2. In a neutral and alkaline soil, oxygen plus two H2O plus two electrons and H2O2 plus OH. Again H2O2 plus OH plus two electron is equal to two H2O. So oxygen and two H2O plus four electron and four hydrogens. An electric current flows between two electrodes and it is proportional to the rate of oxygen reduction. The rate of oxygen reduction is a term related to rate at which it is diffused the electrodes. The increases of current with potential continue until it is limited by the rate of which oxygen can diffuse from the oxygen environment to the electron. As to at the higher potential, the electric reaction rate is limited by a X factor and the current becomes somewhat independent of the potential. A second reaction starts at the potential of 0.7 to 0.8 volt. The second rise is by a reduction of ionic hydrogens to molecular hydrogens because of current is Active division is limited by a maximum rate at which oxygen can be fused to the platinum microelectrode surface, resulting difficulties measuring at the moment of the oxygen since general produce a fusing at platinum electrode to characterize soil oxygen status consist of measuring a current which is proportional to oxygen diffusing through the electrode. It is necessary to consider diffuse theory is a order to complete understand what is actually being observed. Potential between a 0.55 and 0.75 volt can be used for a standard combination size of electrode. However, is also an important factor. So 25 gauges electrode usually gives accurate measurement of ODR value. So over the wide range of oxygen soil moisture, theoretically ODR increase with decreasing soil moisture. It has been also found that an increase in soil ODR as a moisture decreased to a point beyond which ODR decrease with the decreasing moisture content. This may be due to an incomplete electrode wetting excuses and concentration of sulfur in the soil very oftenly showed poisoning or what may be avoided by removing and letting the electrode in the soil. It is one of criteria generally used to determine the oxygen concentration in the soil pores space. It is consisted of allowing the free diffusion of oxygen into a diffusion chamber that was uh, inserted into the soil. The calculated partially pressure of oxygen at 10-minute and interval was used to evaluate the diffusion rate. The determines the rate at which oxygen can be replenished if it is used by respiring plant root or replaced by water. The ODR characterize the soil oxygen condition. There are the various factors that can influence the ODR, namely depth of the soil, temperature, moisture content, soil texture, etc. The ODR decreases with the depth of the soil, indicating that. With an increases in the depth, the concentration of oxygen decrease temperature affect the ODR by increasing soil rate of respiration and the diffusion coefficient of oxygen in water. The solubility of oxygen in the liquid phase is decreases. The ODR decrease as the moisture content uh, increases because of filling pores spaces with the moisture resulting so space for a gaseous exchange. The ODR has come partially implications relationship between that plant root and soil moisture and the aeration status and biological activities in the soil, etc., which ultimately influence the plant growth by affecting various physical and chemical properties of the soil. It has been found that the root uh, growth easing when the ODR dropped to about 20 gram into 10 to the power minus 8 centimeter square per minute. Importance of soil air in a plant growth and biological activity in soil. So soil aeration is an important factor in a crop production. For maximum production, optimum levels of soil are must be maintained, and as well as plant nutrient and what the plant supply. The gaseous constituent of the soil atmosphere plays a vital role in modifying the soil physical, chemical, and biological environment, which is turn influence the growth of plant, enhance uh, yield of crops. So the importance of the soil aeration is in aeration to the soil fertility and plant responses are the generally divided as like growth of a plant and the development of roots. So the growth of plants are adversely affected by a poor aeration, namely the development of plant roots are restricted or inhibited, the absorptions of water and nutrient decreased, the formation uh, of toxicity substance, the encouraged by a poor aeration, especially under a puddled waterlogged condition in case of rice cultivation. Adaptations of plant, the ability of different plant species to grow in soil with the low soil temperature, soil porosity varies greatly. Certain plants such as a right that are adapted to growth without an external source of oxygen. For the roots have a large initial air spaces. Plant adapted to poor aeration, so shallow root system in the upper part of the soil where aeration is greatest. The roots of plants adapted to growth in aeration soils have been founded to carry out some anaerobic respiration of if oxygen is deficient. The effect are detrimental, the relatively low rate and energy output of anaerobic respiration and accumulations of toxic product are perhaps the most important reason. The compacted soil, the root penetration within the impressive layer and restricted, and the such restricted root system are not able to absorb the sufficient moisture and the nutrient for the normal plant growth. Microbial population and activity, soil aeration influence the activity of soil microorganisms and also affect the rate of decomposition of organic matter. The poor soil aeration decreases the microbial activity as well as oxidation of organic matter. The decrease may be due to a lack of oxygen, then with the excess of the carbon dioxide, the deficient beneficial, the different beneficial biological process carried out by a different microbial organism, such as a decomposition of organic matter, biological nitrogen fixation, nitrification, etc., are largely depends upon the aeration status of the soil. Or aerobic organisms are unable to function properly in the absence of oxygen in a soil. The microbial population, therefore, is the drastically affected by drastically affected by a soil aeration. Only the anaerobic and the fluctuative organism functions properly in a poorly aerated soil. This is possible owing the area ability to utilize the combined oxygen, and as a result reduced from of a different element like iron and manages iron or manganese are produced as their toxic concentration to plant. Production of toxic substance, heavy rainfall, excessive irrigation or puddling together with flooding bearings about or reduce the condition of soil or subsequently reduction of element like iron and magnesium and slow rate or incompleted of decomposition of organic matter will take place in the soil, thus the production of various organic toxic acid like lactic and um, batric and the citric acid, etc. And also toxic concentration of iron and magnesium are found in the anaerobic soil condition. Absence of oxygen due to a production of such toxic substance, plant roots get a injury and thereby a lost in their ability to absorb nutrients and water for their growth. Absorption of water and nutrients, effects of aeration on the uptake of nutrients by plants may result from changes in the nutrient availability that occur is in the soil in response to the aeration, or they may result from changes in metabolic status of soil. The plant, the mineralization of nitrogen is generally not affected by the irrigation status of the soil, varies the availability of the availability of other nutrient element like phosphorus, iron, magnesium are increased by a poor irrigation due to flooding. The other micronutrient like copper, zinc show a deficiency under a poor irrigation waterlogged conditions. Poor irrigation decrease the uptake of water are evidenced by the wilted condition of May plant after flooding. The permeability of root to water decrease under the condition poor irrigation. Incidence of a disease, plant roots and soil-borne disease organism occupy the same environment and respond in the characteristics way to a prevailing condition such as the aeration. Change in the aeration may modify the susceptibility of the plant, the virulence of the organism, or both, so that the disease incidence may where with the conditions of the soil areas may affected of the aeration has to mainly many the sensitivity of the disease organism and not the plant cereals are moderately tolerant to poor aeration.